All right, now this is another proof video, but this is going to be a proof using the converse of all those things. Okay, now remember, we have P implies Q is the original statement, and then Q implies P is the converse. At the beginning of this unit, we were given parallel lines, and then we tried to prove, certain things were congruent or supplements. Okay? Now, we're going to have to find or show certain things are congruent, and then that will prove lines are parallel. So on this problem, although converse is all about going the other direction. It's all about proving lines are parallel by showing congruent corresponding, or congruent alternate interior, or congruent alternate interior, or supplementary consecutive interiors. So when we look at our transversal again, so let's just look at a transversal again. I'm just randomly numbering these things. Okay, so we have lines, and we are not sure whether or not those lines are parallel or not. But if you can show me somehow, some way, that angle 1 is congruent to, I don't know, angle 5, then you've shown me you have congruent corresponding angles. If corresponding angles are congruent, then the lines are parallel. Again, you're showing Q, and that implies parallel. Previously, we had parallel lines, and then we made conclusions about corresponding angles. All right, so then that would prove the lines are parallel. If you could show me that 2 and 7 are congruent, then that would prove parallel. If you could show me that 3 and 6 are congruent, then that would prove the lines are parallel. Or if you could show me that 4 plus 6 is equal to 180, that would prove the lines are parallel. Again, we're just using all the things that we talked about. This is using corresponding angles, 1 and 5. 2 and 7 are alternate exterior. 3 and 6 are alternate interiors. And then 4 and 6 are what we call consecutive interiors. And again, these are all the classic Q's. So if you can show me that any of these 4 are true, then we know the conclusion is the lines must be parallel. Okay, so let's go back up to the actual problem of the worksheet. So I have this setup where I have line K and line M, and I know that this angle is 3x plus 10, and this angle is 5x minus 50, and I need to use this information to decide whether or not I know that the lines are parallel. Okay, so what do you know about these two angles? Well, I know they have to be equal. 3x plus 10 has to equal 5x minus 50, because I know vertical angles are congruent. This has nothing to do whether the lines are parallel or not. You can't assume the lines are parallel. That's what we're trying to prove. But I know those guys are congruent because they're vertical. So let's do some algebra. I'm going to add 50 to this side to get 60. I'm going to subtract 3x to get 2x, and I'm going to divide by 2, and I'm going to x equals 30. And I'm just going to write down, dude, I did some algebra. All right, so if x is equal to 30, well then I know that this angle is 100 by substitution, and this angle is 100 by substitution. So let's call this angle 1 and that angle 2. So we know that angle 1 and angle 2 are 180 degrees. And we know that because we can substitute. Substitute. That's an algebraic property. If we know x is 30, then we know that 5x minus 50 is 100. Okay. Look what happened though. Let's use a different color. This angle is now 100, and this angle is now 100. Okay, so let's call this angle 5 for fun. But now, angle 2 is equal or congruent to angle 5, right? They're both equal to 100, right? Same measure. Definition of what it means to be congruent, right? Same measure. Okay, but now I can make the statement that line K is in fact parallel to line M. And why do I know that? Because I have congruent corresponding angles. And now I have my proof. Check. All right, go through this again. Okay. Don't assume the lines are parallel. That's the whole point. We know that these angles have to be vertical or have to be congruent because they're vertical. I can do algebra to this situation and get x equals 30. I can substitute that value back in and show me that this angle and this angle are both 100. But if this is 100 and this is 100, well, those two angles are then congruent because they have the same measure. It's the definition of what is each congruent. And then I can then claim I've shown that these are congruent corresponding angles. That means that K is in fact parallel to M, and the reason is corresponding angles. And it's really the converse of the corresponding angles theorem. It gets the opposite of over here. This said, if, or excuse me, originally this would say parallel means congruent corresponding angles, but what we're doing over here is this guy. That's what we used in the proof. I showed you that corresponding angles are congruent, then I know the lines are parallel. Again, you're pretty much going to use one of these four some point in there to then prove lines are parallel. The converse is just going the other direction. Hopefully this video helps you out, but again, your goal, do not assume the lines are parallel. Use linear pairs, use vertical angles, use algebra, use triangle sum theorem, and you want to work it to one of these situations. Once you get one of these situations, you can prove you know correspondings are congruent, alternate interiors are congruent, alternate exteriors are congruent, or you know the consecutive interiors are supplements, then your conclusion is the lines must be parallel, and that's what you'd write here.